After suffering 7 years in the robotics field with the robots of today, I decided to found a new company and to just change these things, which I thought they need to be changed as soon as possible. I was working with collaborative robots, industrial robots, also with AGVs and AMRs, and I saw everywhere still a very huge gap in the robotics between, for example, Cobots and industrial robots. So they don't complete each other. They have both like advantages and disadvantages. That's one thing. And the other is really like bringing collaborative robots into the field, or like automotive, aerospace, medical, wherever, and using the advantage of being collaborative. I saw there like a huge gap still, because you need a lot of risk assignments. You need to change a lot around the robot to make the robot really be useful. And my thinking is that we shouldn't change the world around the robot, we should just change the robot. So, and that was why I started that.
In this podcast, I'm sharing my passion and curiosity for soft robotics, where we share inspiring stories about the work we do and how we can push the limit. I am Mara Dwayne, and this is Soft Robotics Podcast. Support for this show comes from Science Robotics Journal. I really find Science Robotics to be a great resource for reliable and tangible research, where we can really push the limit of the science we do in robotics. Great way to stay up to date with the published article is checking out the released monthly issue. All the links will be included in each episode description. We will also happen to have a regular conversation on the most published science robotic articles, where also you can contribute with your question and thoughts about the research. Thanks Science Robotics for sponsoring Soft Robotics Podcast.
Hello David, thanks so much for joining us on the podcast. Such an honor to have you here. So, if you can just briefly introduce who you are for the audience, maybe first time listening to you.
Hi, I'm David, CEO and founder of Neura Robotics. I have actually a great goal and vision to bring robotics into the next level because I was before I started Neura, I was also racing 3 other tech companies in the field of robotics and 3D printing, and after suffering 7 years in the robotics field with the robots of today, I decided to found a new company and to just change these things, which I thought they need to be changed as soon as possible. Yeah.
Mm-hmm. So what kind of suffering?
Yes, I was working with collaborative robots, industrial robots, also with AGVs and AMRs, and I saw everywhere still a very huge gap in the robotics between, for example, Cobots and industrial robots. So they don't complete each other. They have both like advantages and disadvantages. That's one thing. And the other is really like bringing collaborative robots into the field, or like automotive, aerospace, medical, wherever, and using the advantage of being collaborative. I saw there like a huge gap still, because you need a lot of risk assignments. You need to change a lot around the robot to make the robot really be useful. And my thinking is that we shouldn't change the world around the robot, we should just change the robot. So, and that was why I started that. And the other part is robots until now are all programmed, they're not autonomous, so they're just doing that, what is programmed. And we are not all of us are programmers, and I think it has to get into the next level where we just make robots cognitive, understand the environment, and to react on the environment, how the environment ever look like. It doesn't matter. And that's actually the main goal of us. Yeah.
Mm-hmm. Maybe I want to ask you, when you have 7 years, maybe the missing pieces to make sure the robots are cognitive. If you can tell us now, recently speaking, and you have Neura now, what's still maybe challenging, or maybe something still not really fully considered when it comes to the cognition and intelligence in the cobot design or ground vehicle robots as you already developed in the company. But what's still missing, do you think, in the future?
I think what's missing we will accomplish actually. So it's the one device thinking, because until now I think the main issue we have is that we separate the robot from all the sensors and we bring them like additionally into every application. But in real, it's the same with a smartphone where we just learned out of it or bring everything inside one device and make it smart. And then that's the only way to actually make it possible. The other big part, which is really missing, I would say, is the understanding of everyone and also the data security stuff. And this is actually one thing which we also took as an advantage right now. So we made our robots right now, they are not online, they're really offline, still smart enough to do all these applications, but it gives us still some limitations. And that's actually the next big thing, how to make it safe in the data security safety I'm talking about, and still being like smart and get, how to say it, learn out of every situations in a very fast way. Because we are somehow limiting the robot world by not putting them into the cloud. But still, everything we accomplish now, it's crazy. Nobody else can ever do it with these limitations. But I think in the future, we should be even more open to clouds or new, ways of computing power inside the device, maybe like edge computing, and that's something, the next challenge. But we are also working on it with several partners.
Great. So I find it very interesting that you have 3 robots, Nave and Neura and Laura. That's right, the names. Why did you choose this variety? Maybe the names first. It's just interesting that you choose these names. Maybe you can explain. And also, it's very fascinating that if you try to solve a problem, but I don't know how do you see the problem from Cobot to, for example, ground vehicles, autonomous ground vehicles. Can you tell us about why you choose this problem in your company, and maybe the names first and why you choose this different aspect?
Let's talk about the names. The names have to be beautiful and somehow have to have a sense, or have to make sense. Let's say like that. And that's why we call Myra is a multi-sensing intelligent robotic assistant, and that's why like M for multi-sensing, AI like for smart, and robotic assistant like RNA. So that's how we put the name together. Before we had another name, it was just MIRA, but it was already in one country already saved for another company. So that's why we just changed it in a very quick way. But Lara, for example, light agile robotic assistant, so simple, light, it tells everything. It's also a beautiful name. And MEF, it's more. It has a deeper, because we have even a MEF, the head of software in our team, we call him MEF. Is a maverick, and we call him MEF, and we just like the name also for the AGV and also fits, and for the AMR and AGV, so mobile autonomous autonomous vehicle, and so that's why MEF. Why did we make this portfolio? And from the first day, right away with 3 of them, because first of all, I made robots already for about over 10 years, so it was very simple to develop and super low cost, lightweight, and also a very good cobot arm. And that's why we just did it at the same time, because we know that cognitive robots, they will still need some time to be also accepted from the market. That's actually a new era, so it will take some time. People will have a question that people will need some time to get used to that. So that's why we have actually Lara as a super lightweight, fast track just going into the market from the first day and just selling them and having a return. In the same time, we are having Neura, which is the next layer, like it's the next generation robot, which we believe in. So it means it's the only, from our thinking, like point of view, is like actually that in the future we will never go around to like a cognitive robot. It will be the next big thing, and we are proving it actually with this Neura already in the industrial fields, also medical fields and whatever. And math, because we believe that just having a smart arm or even just a lightweight robot arm is not accomplishing everything. We are also, as humans, made in a perfect way by being mobile, and that's why we thought it's also right from the first day already working into this field that we can make our robots in the future also mobile. We can use them as a standalone, also very fast track to market. We have them developed in a very short time also, and but now working on the cognitive mobile robots, and that's actually also taking time, but also we will present very soon some really new combinations of it. Yeah.
Great. So I would like to ask you about the design, because I think the design also very interesting and quite fancy, but about the functionality as well. And I assume that you try to combine both the design aspect and functionality. And how is it challenging for you? Maybe I want to ask you, in the process, there's something, maybe mistakes or lessons that maybe if you can share, and that's something bring new perspective in the design and also functionality. Because I think it's very interesting. I assume that you try to combine both in the design, yeah.
I think through collaborative robots, we already try to get closer to humans, so the design aspect is there. It's very important also. And I think with cognitive robots, we will go even closer to humans and have like an even interaction with the human like every day. So it means we will talk to the robot, we will show the robot what actually needs to be done and see robot more as a really helper assistant. And we believe that a design is a very huge part of it. And I think this is also all the other companies before us, like Apple or like Tesla. They also have this design thinking. And I think also even in the industrial field, it will be even more and more a super huge advantage, and also like just more, how to say it. I feel more comfortable with a nice designed robot as an assistant, than just something which looks like a piece of metal. And also I think the trust, getting more trust into the robots, that they will not kill us. They are actually there to support us and help us. And I think this is why. Yeah, design was from always the most important, one of the most important parts by creating new robot. Yeah.
Mm-hmm. Maybe I want to ask again about the cobots, the actuation and sensing. And I think also I saw your videos explain about the interesting feature about safety, if we speak about human safety detection. And maybe that's interesting part. Maybe if you can tell us what be advancement if you try to increase the level of cognition in the cobot, for example. What would be possibilities in the motors, design, or actuation and sensing part?
That's actually, I think the safety part is one of our major advantages of Neura, because from the first day we're considering safety as the topic number one, because we believe going closer to humans we need to put more safety in, because we cannot just consider that, if it's happened, it happens or whatever. And until now, there's a lot of norms which are telling exactly how to use robots, how close can we go to them. That's actually the biggest issue and the biggest challenge I had before. So I did cobots, which were just force reduced, for example. And the interesting part was that robots have to consider all the time that there is a human next to them. And that's why cobots are super unproductive and super slow. And also you have to do a lot of risk assignments to really let a collaborative robot work as a collaborative robot. Mostly we are using them just in the cooperative part by adding a lot of sensor around to make sure that there is no accident. And that's what that bothered me a lot, because 95% of all applications in the collaborative fields are not used properly, and also are actually against the norms or not even used as a collaborative robot. And that's why I thought I need to change something, and we developed actually from the first day already a sensor to make the robot be as smart that the robot knows when there is a human or there is no human close to him. So, and I think this is actually the biggest game changer in the robotics field, because until now, everyone who is announcing they're bringing robots into homes, robots into like even factories, closer to humans, more AI inside, whatever, they will get one day a very huge issue by facing the safety issue. Or because then they will realize, oh man, I developed now all this cool stuff, but I cannot use it. I cannot bring it into homes. And that's actually the main reason what I say. The main reason why we don't have robots at home is actually the safety part. It's not just the fear of the humans. It's more there is no solution for that, because robots until now don't know what's a human. So they can simply, if they have enough power to help a human, so it means if they have payloads, then they can also kill a human, and they can also hurt a human. So this is why we believe we are the only one worldwide which can actually go into households and go into fields where we where we work directly with humans, because we are the only one worldwide which made a sensor which can actually distinguish humans from other objects and also react on that. And everything what we do is actually dual channel, so redundant and also diverse. So every decision will never be wrong. There will never be a wrong decision of a robot. And that's actually something we made sure. And that's also why we are super confident that we are the company which are going faster into every home or really working next to humans in every kind of fields than any other company in the world.
Mm-hmm. Great. Maybe also I find interesting in the design of the Cobots in Neura about zero force of gravity. I think that's kind of form of physical intelligence. Maybe I don't know. I can assume it's kind of physical intelligence, and I would like to explain more, because I think it's a very cool feature embedded also in the Cobot you developed here.
Yeah, how do we do it? So we have actually a force torque sensor in each axis, so that we know exactly when you like simply touch somewhere on the robot, we know exactly where you touched the robot and with how much forces you applied on the robot. It's more to just have like all the information and never squeeze somebody or whatever. That's one part of it. But we also have in our we developed the first super low cost force torque sensor, which we have like on a TCP part. So it means on the front where you have the hand, for example, or a gripper on. And this is for 6 degrees of freedoms. And it's the first and only really affordable one, because until now we know like all these companies, like I don't want to mention them now, but they're good, they're doing a great job. They have like the gain strain related versions, but in our part we just made a super low cost with just much more flexibility and also advantages if you compare it. And so it's also included in every robot we are created. So we have torque sensors and force torque sensors on every robot to be able to feel. Yeah.
Maybe I want to ask you if there's maybe controversy or disagreement in the way of the design or embedding the functionality in the Cobot. Do you have any encounterment like disagreement, or you disagree with approach maybe in the market about the Cobot design? This is not maybe the right way. I believe that's what I'm doing and Neura. Yeah, that's something I don't know if you have it.
Yeah. Yes. Like if you look at Neura, for example, the cognitive robot which we offer is different made. It has a different setup. It looks a little bit different, and it has a sense behind. Yes. So we have a double bearing concept, because especially in this Axis 2 and Axis 4, it's a 7-DOF robot, to have actually not like much more stiffness, even using still an aluminum structure. We have the whole robot setup is also made like that we can use a 6 or 7-DOF robot as the same robot. So we are just leaving the third axis in or out, and we have a 6 or 7-DOF robot. So it's super unique if you compare it to others. And I think the whole structure on itself is different, because we're all experts, and we're the only one right now also in the robotics fields with the accuracies we have. If you compare us to every robot in the whole world, we are much more accurate than others by firstly using secondary encoders, which we also develop by ourselves. So we have about 25 bits encoders in every axis. And also by using an amazing structure which has a super, by temperature change, we have a super linear behavior of how do you call it, temperature extension or so the change by temperature, we are super linear. That's why we are calculating out in a perfect way. We can do a lot with our software. I think everything we thought, so that's I think the special part is when we started developing these robots, I did already develop a lot of robots before. So, and I think every engineer worldwide is made like that. So if you develop something and if you're ready with that, you're mostly not satisfied. So you will think, okay, next time I'm getting the chance to build a robot again, I would do it differently. I would do it better. I would do it in a different way. And that's exactly what we did. Like I did 7 years of robot development, and the 7 years of doing industrial robots, cobots, I had a lot of ideas. How would I do it differently next time? And that was the big wish list. And the amazing part is when we started here, we started from zero again. So I could put just a wish list on the wall and say, hey, guys, we have to do the robot faster than any robot in the world. We have to do more accurate than any robot in the world. We have to do it like more sensitive than any robot in the world, and cognitive, the first cognitive robot in the world. So, and that was the goal. So for sure, when we started with 12 persons, so 12 engineers. We were all only developers, and everyone, I think, thought this guy is going crazy. It's not possible to be better in everything from the first day. And but we did it, and we made it in the most record time I think ever somebody can do it, because we had a very clear goal. 7 months after founding the company, we have the first robot prototype, like fully functional with all these functionalities which on the wish list. We said 1 year after founding the company, we sent the first robots out to customers. And but we did it even in 10 months, and that's why I think we have there even accomplished exactly that. It's a super unique how we built the robot. It's super unique what sensors we use inside the robot, and also like the abilities, the cognitive abilities which we have in the robot. So, and yeah, that's actually just put all together.
Yeah, that's really impressive. Maybe I want to ask you now, because I think this is a huge responsibility for, especially in robotics. What's something still you stay up late every day just thinking? Is it a technological part, or just letting people, maybe to more acceptance to the robot, for example? I'm just making up. I don't know what's really challenging aspect, because I hear a lot of people saying that maybe you make a really fascinating robot, but maybe it doesn't work, it doesn't fulfill the needs exactly. I think you understand what I mean, since you suffer for 7 years. And it's not easy. It is not easy. And I think what you do is impressive. So what's still, every day thinking about this thing is very challenging yet.
I think the biggest challenge to bring robots in every household, for example, that's our goal. So our big goal is that one day everyone has a robot as an accessory in every home, and also as a useful assistant. The biggest challenge, I would say, is the pricing thing, because we can do like the craziest systems, but if they are not affordable, nobody will ever buy them. So, and that's also one of the biggest challenge we are working on, is making robots amazingly good in performance, in also make them like pretty good, like also like how they look like, but still also being super affordable. Like it means like a pricing of like maybe an e-bike or something where we can say, okay, like 3,000, 3,500, like that. I'm talking about euros, dollars, it doesn't matter. And that's actually the biggest challenge we have. And right now, I still think that's one of the biggest challenges. Still keeping performance, but also getting like breaking this barrier of pricing, and that's what we are from the first day are concentrating on. That's why we do a lot of sensors, motors, everything we do by ourselves, even own gearbox, which we develop, just to be one day the robot which everyone can just afford worldwide, and still having this look and feel and performance.
That's a good point. Yeah. Maybe I want to ask you about the risk, since I think your story about doing something in not traditional way. How do you view risk, especially as you're on the market? So, is it something concerning to when you try to push the limit of the street robots you're doing, or if you can just highlight the way of thinking about taking risk and ideas, for example?
Yes, I say, like, if you really want to change something, you need to risk. And I think the risk give you like a new opportunities, and also I think you need just to have like the team for that. Like you can like if you have a team which are how to say it, which will not go through also harder times where things are not working, then better don't risk. Or but if you have a great team, and if you believe like in really all in one thing, is like changing the world with robots and bringing robots closer to humans, and find a way for that, then you're touching exactly the things which everyone tells you to not touch. And this is exactly what happened actually to us, Neura, and also to me personally. Like the people all were questioning, why do you take the risk and leaving a company where you just established and where you were successful already with the robots? Simply because we want to change something. First risk, personal risk. But later, like when you're starting a company and you're getting money, the first money from investors, you're also not allowed to risk it. So the investor will tell you, hey, do exactly what you learned before, don't risk it. And then you have to take the decision again. Where we did the decision that we would just risk it again. And we did, and we made it successfully. And how did we do it? Very simple. Everyone right now, and that's actually the whole difference from us to all the other robot suppliers in the worldwide. Every robot supplier is taking sensors, motors, gearboxes, everything like out of some boxes or somewhere of some suppliers where everyone takes the sensors from. How can you be better than the others if you're using the same stuff? So it's so you can do a little bit of software, yes, okay, but that's not a very bring a big change into robotics. So this is why we decided from the first day we developed our own sensors for positioning, for example, like encoder technology. But you need also to make it smart. So it means you don't risk it by not having any knowledge and just build it somehow. No, it's not. You're taking the right person for that, which you believe in. Say, like with this person, we would just go through this risk. In the same time, we did it like for the motors. We did it for the Vostok sensor. We did it like for everything what makes us faster than any robot in the world, more accurate, more sensitive, or more intelligent is like own development, because then you're only sure that you will stay also advanced to all the others in the world for some time. Because if you're taking out of the box, everyone can take out of the box. So this is why you should risk, you should change if you want to. I think that especially you need to make a decision in which field you're doing this risk. Right? We all know that robotics will be the next big thing. So you should risk it there. You should not like maybe now risk it again in the automotive field, because there's now the Tesla doing their risk already, and they have like a huge power behind. But maybe in the robotics field where we see over time there was not big risk, and that's why it was staying for 50 years in the same place. But now we have to do it, and that's why we did it. Yeah.
That's excellent. Maybe a few questions left. I want to ask you, what other aspect of cognition, speaking Cobot, do you think still need to be explored in the market? If we speak about cognition, what is maybe the fullest potential that when you sit and think, maybe that's the missing aspect in cognition, or maybe I wish to enhance this aspect of cognition in cobots or robotics?
I think at the first time for us was the hearing, seeing, feeling, and reacting and thinking, like the first cognitive part which we concentrate on. And And that's also something we are super good in. I think the next is actually like this the how to say it, the prediction of things. This is the biggest, I think, ability, and that's something where we judge on good assistants. Or like if we say, like if you personally think about your assistant, like how would you judge on your assistant? Or mostly, if I talk about a very good assistant, I will talk about, hey, the assistant is looking forward. It's making a decision. I don't have to think that everything is already prepared. I don't have to say something. It's always there. That's a good assistant. If you talk about a bad assistant, you always think you have to tell everything 10 times. You have to tell it every time, new again. Even the person did it already before, the assistant did it before, or whatever. So this is how you judge. And that's exactly the main, how to say, cognitive ability, which, and also the ability of a robot, which we need to have a good assistant, accepted assistant in every home. And that's what we are mostly working on. Or is like having first the abilities of seeing, hearing, and feeling, and then now using this how to say it, these abilities and also the senses, and putting combine it with AI to being able to predict things, learn things, understand things in a very simple way. And that's, I think, the biggest challenge also, because our brain, human brain, is like perfectly made, and to just reconstruct that one, it's like it's something, I think, it needs some time. We can do we can always concentrate on little parts, and that's how we do it. So we let the robot being like responsible, for example, for cleaning work, and then you can just concentrate on that. But in the same time, like we humans are made that we think also about all these other things around. It's not so easy. So that's why we make it step for step, but it's a huge challenge still. Yes.
Yeah. Maybe a quick question about the user interface, because I think that's also a very important aspect. For example, in self-driving cars, there is some user interface not really intuitive and really annoying. And I think this is really important aspect, how you have this intuitive user interface for lay people that just you can do anything with the robot. Can you tell us about the user interface? Because I think it's very important. Yeah.
I call user interfaces like the interface, or how to use something, and how do we humans are also used to just simply talk to each other in a natural way, and also to gesture, to show something by pointing on something, whatever. And that's actually the first user interface which we implemented in our cognitive robots. So you can simply talk and gesture things. Make a small example. That's also something which I can show you like when you visit us. Like I will simply go to Myra and say, "Hi, Myra." She will ask me, "Okay, what can I do for you?" Then I will just take this glass and put it here inside, and she will understand that, and she will just do this. Exactly this what you told, and she will do it all the time. If you say, "Now repeat," and that's one way. Yes, that's the best way, I think, and it's also something where the people are most impressed when they see Myra, and then they, the first time, understand what cognitive abilities she has. But in the same time, you can also use like a standard tablet teach panel, where you simply have a graphical user interface. It's also something we humans adapt more and more by not talking to each other, but just using smartphones, and that's also one way of communicating with her, just in a very simple way. So we have everything graphical user interface, drag and drop, just simply having pictures. She gives us like a feedback, or give us only one way and ask us questions to accomplish them. So that's one. But I believe in the future that we will not have these interfaces a lot. It's more about doing something super complicated or whatever, which the robot needs to learn. I think there we can use interfaces like that. But in the future, I believe in a natural interaction by voice control, by gesture control, and also like all the vision possibilities we have of the robot. Because I believe, and that's actually the crazy part, where I say no robot right now is really autonomous. Even you see like the craziest videos in somewhere from all the top companies I don't want to mention again. you will actually figure out behind the scene they were programmed. So and that's the biggest challenge we have, and that's actually something we change as Neura, is that our robots are not programmed. They understand things. They just do them by the understanding. And a simple explanation for that: if you look into your house, you will never find the exact same way of cleaning things or whatever. It's like or every day things changing. You need to adapt. You need to react. You need to, and that's why we don't have robots which can really help us in our households. And I don't believe that everyone has the skills of really programming the robot. So that's why you simply tell the robot what to do, or the robot has to react on itself by predicting things, understanding things. Or, yeah.
Great.
So maybe I want to ask you, what are potential customer for you? What you're targeting for? If you can just elaborate, who are your potential people that like for these 3 robots?
We are right now launching like a new ecosystem, which we call Neuraverse. And there we have like different layers of, I don't call them customers, partners, because we are not really working with end customers, for example, because we are not going directly there and solving something. It's more about we are using the already networks which are already there, and also working with partners together which have already like a concern, an issue which they never could automate or never could do with the standard robots of today. To make an explanation, I can unfortunately not really name a lot of them because I need to be confidential, because we are also presenting this Neuraverse in June on the Automatica. It's more about having already like markets, for example, in the labor automation industry. So here we are cooperating with the number 1 of this field by just making things possible which were never possible before. And they have already the channels or how to get the robots out through their channels. And at the same time, we are working, for example, with one in the metrology field, which know exactly, until now, there was no maybe autonomous robot arms, which can also measure the same way, in a very accurate way, for example. This is also something which we can solve with our robots, because they're about 10 times more accurate than any robot in the world. And then, so we are reaching their accuracies like 6 microns of the robot arm. And so you can use it for measurement devices or metrology fields. So, and these are actually, so we have the technology partners, which are developing on our platform. So this is actually what we call Neuraverse, is like the platform to advance humanity. It's more about building with them systems with always the same core thinking: robot, AI, sensors, and making things possible which were not possible before. All right, so that's the thing. It's like one layer, and then we have also the next layer where we also work with others call them, for example, competitors. And we are working there because we have already advanced sensors. We have advanced robots than others, but we are not in this size, and also we are not as we think different than every company in the world. We just say, hey, we are not competing, we are cooperating. Our goal is to advance humanity. Our goal is to bring robots in every home. To do this, we need to have like partners for that, which are already in this field for many, many years, and we can support them by bringing our sensors in their fields, by bringing our AIs to their robots. So this is how we actually cooperate, and that's why we are also very successful. I think we don't have competitors, we don't have foes, we only have friends, and that's actually the whole thing, because our main goal is to change something and serve humanity.
That's really awesome. Maybe that's the question: what makes you fulfilled? And if there is an advice you can give, or maybe given to in this process, and you think really important advice, and also what makes you fulfilled as well.
Yeah, like I can just talk like about my personal feeling, and also which I think it's important to get this change into the world, is actually that we do something where we don't really change the mindset of the society of today. Because if we look in the future, we will see that robots will come to every homes, a robot goes everywhere, so we need to set some rules. We need to also, how to say it, to accomplish a lot of different, how to say, challenges. And I just think that, yeah, our time right now is too short to just build or, how to say it, to compete, to copy or to whatever, to have this competition, like a weird competition, how it is like the past years. I think we should stick our hands together because the market is super huge and also we have a lot of things to accomplish. And so my personal goal is to have like a very big impact with our technologies which we are developing to make the world a better place, to give humans more time to just change our mindset in that of really just having super hard work or whatever and then feeling good through that. It's more about like maybe finding new ways of getting payments, of filling up the retirements force, or like I think there is ways with robotics and we should use and we should work on and we should think all together about it. And that's what, but it's not really an advisor. It's just a mindset which I personally live, and also which I wish that I have more people around me and also companies around us which are thinking like that and bringing the real change to the world and make the world a better place in the short period of time which we are living. Because, I mean, the time is fast running by and we should change something, yes. Yes, I would love to invite everyone to Automatica in June in Munich. It's a trade show, and we will first time really show what we actually worked on. So it's not just building robots. It's actually the whole ecosystem, how we believe it should look like, and also we will present our partner networks, and we invite like everyone who wants to change the world and also do something crazy and think about things which were not possible today and just make it possible with us together. So we invite everyone. It's in June, I think 21st. And yeah, I think it's worth to go there and to see something crazy, which we will present. That's actually something. And yes, you feel free to just contact us and our team if you're looking for an amazing job, for example. We have right now a lot of openings. We are super happy about people with a great mindset. So we invite everyone.